Okay, for question number 8, 300 resistors connected series with 5 microfarad capacitor. So you have resistor and capacitor. So I draw the graph like this. I draw the circuit like this. So this would be your RC circuit. The voltage across the resistor is given by this one. So this is the VR with respect to time. So normally they will give you VRMS with respect to time, but this time they give you VR. So that one specifically for this resistor. Okay, write down the equation of the current in the circuit. So current in the circuit, because this one is in series, so current inside the resistor inside the capacitor is basically the same with the IRMS. So if I want to use the general equation is I equals to I naught maybe I can write this one in terms of cos, because I'm following the VR over there. So you know that current and voltage will always be in phase, so it will be the best if you use the same type of graph. So if I were to draw, then you will expect the current to be like the voltage to be a cos graph and current to be like this as well, okay, because it is in phase across the resistor. So I need to find I naught first. To find I naught, I can use V equals to IR. That one's from Ohm's law. So if I were to use VRMS, IRMS, this one would be Z. Okay, because that one's for the whole circuit. You have to consider capacitor and resistor. But in this case, I would like to use VR. So this would be IR, V naught R, V naught. But because you only have one types of current, so basically it would be I naught. R is given 300. So you can solve straight away. I naught is equals to (1.2). The value of 1.2 I got it over here, because this is your V naught at R. Divided by the resistor of 300. So I got here is 4 times 10 negative 3 ampere. Now I can substitute back inside here. Okay, the omega will be the same with this one, because the omega depends on the power supply. So you will expect omega equals 2 pi f. So as long as it is come from the same power supply, omega remains the same. So I just going to write it again. I equals to 4 times 10 negative 3 cos 2500 T, where I in ampere and T is second. Equation number B, they want to determine the capacitive reactance. So XC equals to 1 over 2 pi FC. So by now you should be familiarized yourself with the term reactance. That one represent X. Kalau impedance, Z. So this will be 1 over 2 pi F. So 2 pi F is basically just omega. You don't have the values of, you can calculate F if you want to, but it would be a waste of time. So I just write that as omega C. Omega is 2500. Okay, so I think I have to do it down there instead. And capacitance is 5 times 10 negative 6. Okay. and you can solve this one. You should get 80 ohm. Here the unit is in ohm because this one is reactance. Okay, for question C, they ask you to write down the equation of the voltage across the capacitor VC. Okay, so if I were to draw the phasor diagram, it will look something like this, VR, VC and I. So you can see clearly that VC lagging by VR by 90 degrees. So if I were to draw my graph, it will be something similar to this. So this one in terms of time, the VR actually is cos, right, is a cos function. So you will expect that the graph will look something like this. Okay, but the VC is lagging by 90 degrees. So actually it is start from behind here. Okay, so I think I'm going to draw it over here, and I'm trying to. Okay, so you will expect this is like the imaginary axis there. So the voltage is here, already here, but the current is over here. Sorry, the voltage is over here, the VC is over here. So it is lagging by 90 degrees. I'm not going to draw it over there. I'm going to draw it over here. So if I were to explain more, the voltage already at the maximum, the current still, the VC is still at the minimum, and then VR start to move and go to the minimum. VC now start to increase to the position of VC just now. So that's why it's always lagging. So you can see clearly this is a sine graph. So if I were to write or use the general equation, it will be VC equals to V naught C sine omega t. So V naught C means the V naught across the capacitance. So I can use V naught C equals to I naught C XC. Okay, so all of these is actually across the capacitance, but the I naught C is equals to I RMS. So basically it is just I naught So the I naught C is I naught. So it will be 4 times 10 negative 3. And we already have the values of XC, which is 80. At 0.32 volt. So the solution would be (0.32 sine 2500 T). Okay. There, I is in ampere. Sorry, I'll copy this one. It's not I, it's VC. Tak apa pula. Where VC in volt and T is in second. Okay. So I skip question 9 and 10 and we go straight to question number 11. Okay, an alternating voltage V with frequency 150 is applied on a resistor in series with a capacitor. So you know straight away that this one is a RC circuit. The values for resistance and capacitance is given, as well with the frequency there. First question, I want to find the reactance of capacitor XC. So the formula for XC would be 1 over 2 pi F C. So you just substitute all the value. 1 over 2 pi 150 2 times 10 negative 6. This one should get 530.52. Okay, jangan salah letak unit. The unit would be in ohm. So this is basically just a resistance, but this one is called reactance. It can be total impedance of the circuit. So like I told you previously, you can use this formula straight away. R square plus XL minus XC square, and then whichever that's not in the circuit, in this case XL is not in the circuit, you put your hand over there, so you left with R squared plus XC squared, because this one got square, so that one become plus. So it will be square root of 300 square plus 530.52 square. Here you should get 609.47 ohm. Still ohm, because this one is impedance. Just see, they want to find the phase angle between current I and in the circuit and the voltage. So even though the question didn't ask you to draw the phasor diagram, but in this case it will help if you draw. So maybe I can draw the phasor diagram first. You have VR, and then you have VC. I'll be in this direction. Okay, so VRMS should be somewhere over here. So if you draw, you get some ideas what will you be calculating. If not, then you basically just calculate lah. Still get the answer, but most of you don't understand. So the phase angle is the phi here, the angle between current and VRMS, because say that this one is V applied. V applied is VRMS. Okay. To solve that one, maybe I can use. I think it's mainly formula. I can use tangent, I can use sine, I can use cos. So it's either I can use this one, I can write in terms of this. Okay. Let's see if I use cos. Cos phi is the power factor. You don't have to use this one. You can use sine or tangent. It doesn't matter. It will be R over Z. Okay, so even if you didn't able to draw this one, katakan kamu tak lukis, at least you can memorize this thing lah. Cos phi is equals to R over Z, and in this case the question want to find the phi. Resistance is 300, Z is 609.47. Obviously you can use V as well, but you don't have those values. Okay, so if your calculator is in radian mode, you will get answer in radian, which is 1.06 radian. If you use degree, you get in degree. Okay, it is 60.51.